To find an inverse function, you first have to introduce the y. Switch x and y, so instead of y, you put x. Instead of x, you put y. And now you have to solve for y. Okay, there are several things that's attached to y. There's a 1/3, there's a 2, plus 1, minus 5. Which one should be removed first? Minus 5, because if you look at it, that's done last, right? If you were to compute the right side with some value of y, you would add 1 to it and then raise it over 2 and then multiply by 1/3 and subtract 5. As you can see, 5 is done last. The second to the last is 1/3, so that should go away next, and so on and so on. You just do the reverse order to get rid of something, okay? If you want to undo everything that's done to the y, you have to do it in the reverse order. So let's add 5 both sides. Which now gives you this. How do you get rid of 1/3? Divide by 1/3. Okay, so you can divide both sides by 1/3, which is going to get rid of it. But see, this one has a fraction inside a fraction, so you have to simplify that. So let's try to simplify that. How do you simplify x plus 5 divided by 1/3? You use keep, change, flip. So you keep the top, and then division, this division should be changed to multiplication, and 1/3 should be flipped. If you flip 1/3, what do you get? 3 over 1, which is just 3, right? So you end up with 3x plus 15. Okay, so we are going to rewrite this left side as 3x plus 15. By the way, the smarter thing to do is actually to multiply by 3. That gets rid of this 1/3 faster without having to go through that. If you just multiply by 3 both sides, then 3 times 1/3 cancels, right? That's much faster. But, you know, even if I say that, a lot of you are going to end up doing this, so I still have to teach you how to do it that way as well. Okay?
So multiplying by 3
would be a lot faster, okay? Yeah. But, you know, I realize that it doesn't really matter how I teach it. You're going to do whatever you're used to. So I have to remind you that as well, right? Okay, so now how do you get rid of 2? Log base 2. You take log base 2. That's going to cancel the 2. And now finally you have to get rid of plus 1 by subtracting 1 both sides. And that gives you y as log base 2 of 3x plus 15 minus 1. It's important to have the parenthesis around 3x plus 15, because if you don't, then it has a totally different meaning. Okay, you're applying log base 2 to both sides, so you're applying log base 2 to the entire 3x plus 15. In fact, if you don't have this parenthesis properly, that will be 1 point off. Okay? And in the quiz tomorrow, if it's 10 points and you get 1 point off, that's actually quite a lot. Okay, so don't disregard the parenthesis. All right, so we're almost there. That means the inverse function is this thing that you see, log base 2, 3x plus 15 minus 1. But then if you read the question, you're supposed to find the domain as well. How do you find the domain? What's the procedure for finding the domain? When you see a log, yes? Whatever that's inside the log, right? And you want this to be greater than 0 because logarithmic functions cannot have 0 as an input nor negatives in the input. So it has to be positive. And you just solve this. You subtract 15 both sides to get this, and you divide both sides by 3. Okay, should I change the inequality? When do you do that? When you divide or multiply by a negative number, then inequality should change, but this time you're doing by positive, so that doesn't change. And therefore you get x greater than negative 5. What is that in terms of interval notation? Negative 5 until infinity. Okay. So this one, as well as this one, will be the solution to the question.